Welcome to solverfy.
Silver sulfate, or Ag2SO4, has a KSP value of 1.5 times 10 to the negative fifth. Let's start by writing out the equation for a saturated solution of Ag2SO4. So Ag2SO4 solid partially dissociates to 2Ag plus SO4 2 minus, each of these in the aqueous phase. Silver sulfate. So the KSP expression is the concentration of Ag plus squared, because of this coefficient of 2, times the concentration of SO4 2 minus. Silver. So we want to find the molar solubility of Ag2SO4 in 0.22 molar AgNO3 and 0.22 molar Na2SO4. Let's start with our solution of 0.22 molar AgNO3. So we can write an ice table where our initial concentration of Ag plus is 0.22 molar. This comes from our AgNO3 that begins in the solution. We then start with 0 molar SO4 2 minus, and we can ignore Ag2SO4 in this table since it's a solid. So our change is then some unknown x. For SO4 2 minus, it'll just be plus x, and for Ag plus, it'll be plus 2x, since we have this coefficient of 2 out in front. Our equilibrium is then just our initial plus our change. So for Ag2 plus, that's 0.22 plus 2x, and for SO4 2 minus, it's just x. And now we can plug these values into our KSP expression and solve for x. So our KSP, 1.5 times 10 to the negative fifth, is equal to 0.22 plus 2x squared times x. Silver sulfate. We can try making our small x assumption here. And if we do, we get the expression 1.5 times 10 to the negative fifth is equal to 0.22 squared times x. Silver. Solving this for x, we get 3.1 times 10 to the negative fourth. And plugging this back into here to check for our assumption, we get 0.22 plus 6.2 times 10 to the negative fourth, which is still 0.22 to two significant figures, so that validates our assumption. Silver. X is equal to our molar change here. So our molar solubility is just equal to x, so 3.1 times 10 to the negative fourth molar. Silver. Now for a solution of Na2SO4, we can do a similar thing where we start with an ice table. Again, we can ignore Ag2SO4 since it's a solid. Our initial concentration for Ag plus is 0, and our initial concentration for SO4 2 minus is 0.22 molar, which comes from our 0.22 molar solution of Na2SO4. Our change is the same, so plus 2x plus x, remembering this 2 because of the coefficient before Ag plus. And our equilibrium then is 2x for Ag plus and 0.22 plus x for SO4 2 minus. Again, we can plug our values into this expression here. and we get 1.5 times 10 to the negative fifth is equal to 2x squared times 0.22 plus x. So we can again try making our small x assumption here. And if we do, then we get the expression 1.5 times 10 to the negative fifth is equal to 4 times 0.22 times x squared. Solving for x, we get 4.1 times 10 to the negative third. And this validates our assumption. Again, now that we have our value for x, we have our molar solubility for Ag2SO4. 4.1 times 10 to the negative third molar.